Okay, in the previous video, I talked to you guys about how to calculate molarity, percent by mass, and molality. And so the fourth concentration unit is mole fraction. So let's do a quick example of that. I've already written it up on the board, so we should get through it pretty quickly. Basically, you've got a solution of iodine and methylene chloride, CH2Cl2. And the information is that you've got 1.50 grams of iodine and you've got 56.0 grams of methylene chloride. And we want to know the mole fractions of each, okay? So remember, in order to do mole fraction, you need moles of everything, okay? So first you convert your 1.50 grams of iodine to moles using molar mass of iodine, and you get 0.00591 moles of iodine. And then over here, no idea why I have so many sig figs. Maybe, yeah, I think that's what it was. Originally, this had two. This is why I continued it on this way. So I went with 4 sig figs here. All right, so anyway, I went 56.00 grams of methylene chloride, used the molar mass, and I had 0.6588 moles of methylene chloride. All right, so now I'm going to figure out the mole fraction of iodine. So you put your moles of iodine in the numerator, and then the sum of all the moles of everything in the solution in the denominator. So I'm adding the moles of iodine with the moles of methylene chloride down here. This divided by this. So if you're going to do it all together, make sure you put parentheses around this. This, press divide, and then open parentheses, this plus this, close parentheses, press equals. And this would be the mole fraction of the iodine. Now, to get the mole fraction of the methylene chloride, you could do the same thing. You could put the moles of methylene chloride in the numerator and then the sum of all the moles in the denominator and press equals. Or all you have to do is go 1 minus this, because we know that mole fractions always end up as 1. When you add up all the mole fractions, you'll always get 1. So if you just have two substances, if you know the mole fraction of one, to get the mole fraction of the other, 1 minus that, and you'll get the mole fraction of the methylene chloride. Okay, so that's that. The next few problems are going to be super important. I'm going to teach you guys how to convert one concentration unit to another. And a lot of students have a lot of difficulty with this, but honestly, if you focus on the units, it's pretty straightforward. But a lot of people just look at numbers and don't look at units, and so they get confused. So follow along, and hopefully you'll be fine. All right, so I've got a 10% glucose solution. 10.0% C6H12O6 aqueous solution. So I know that I've got glucose mixed with water. Glucose is the solute, water is the solvent. And I want to find what this is, what the molarity is, and what the molality is. All right, so that's the first problem. We want to learn how to convert percent by mass, and this is mass by mass. We want to learn how to convert percent by mass to molarity and percent by mass to molality. How do we do this? The first thing you want to do, anytime you are given percent, write it out as, like if you got a 10% on an exam, it's 10 out of 100. So you're going to write 10.0 grams of glucose, C6H12O6, per 100 grams of solution. That's what 10% means, okay? I want to convert that to moles of glucose, C6H12O6, to over liters of solution. Okay, how can I convert the grams to moles? This top part should be really easy, right? you just do molar mass and you convert your grams to moles. Well, how do I convert mass of solution to volume of solution? We learned something earlier on in the semester. If we use this, you can always convert between mass and volume, volume and mass. What is it? It's density. So we have to be given the density of a solution anytime we want to switch from mass to volume. And for this, they've given us the density as 1.04 grams per mil. So density is 1.04 grams per mil. Okay, so I'm going to focus on one at a time. I'm going to first focus on the top one. So I'm going to go 10 grams of glucose, C6H12O6, and I want to convert that to moles. 1 mole of glucose, C6H12O6. Add it all up, it's going to be around 180 grams of glucose. Could be 180 point something, but close enough. Okay, that way I get my moles of glucose. And then I'm going to take this thing down here, this 100 grams of solution, and I want to convert it to volume. So I'm going to go 100 grams of solution, and I'm going to use the density, flip it over, 1.04 grams per 1 mil. This is 1.04 grams per 1 mil. I'm flipping it over so that your grams cancel and you end up with milliliters. You guys see what I'm doing here? All right, so now we can pick up our calculators. And let's take a look here. All right, 10 divided by 180. And that is 0.05555. And I'm just going to round it to 3 sig figs. So erase this here. Put equals 0.0556 moles. All right, so I have my moles. And now I want to divide 100 by 1.04. 100 divided by 1.04, and then that is 96.2 milliliters. All right, so how do I get molarity, capital M? Let me erase this for now here. What do? I'm going to put my moles, which is 0.0556 moles. And then I'm going to take my volume, but I'm going to put it in liters. So 0.0962 liters. You guys see what I did? Okay, so now I plug it in. 0.0556 divided by 0.0962, and you end up with the molarity of 0.578 molar if we are going to do it to 3 sig figs. Okay, so that's how you convert a percent by mass to molarity. Percent by mass to molarity. You put units on the percent by mass, you then focus on the numerator and then focus on the denominator, okay? And put it together and you got the molarity. Now let's do the same thing, but convert our percent by mass to molality, all right? Again, it's all about the units. Okay, let's see how we're going to approach this. We have, remember, it's a 10%. So 10.0 grams of glucose per 100 grams of solution. And what units do I want to change this to? I want to change it to moles of glucose, moles C6H12O6, over kilograms of solvent. What is the solvent? Remember, this was an aqueous solution, so kilograms of water. That's what I'm looking for. So I want to go from percent to molality. Okay, So we just did earlier the grams to moles of glucose. All right, that's a straightforward molar mass. How do I convert grams of solution to kilograms of water? Well, remember, your solution is made up of solute and solvent, right? And we know that in this 100 grams of solution, you have 10 grams of glucose. So how much water must there be? It must be 90 grams of water. Where did I get that from? Well, 100 minus 10 is 90. So I'm going to rewrite this. I'm going to write 10 grams of glucose over 90 grams of water. Okay, now it's really easy. I can convert my 90 grams of water to kilograms, right? And then I convert my grams of glucose to moles. Boom, I've got it. All right, so let's go ahead and do that. I'm going to just go ahead and actually do it separate here. So 10 grams of glucose. I shouldn't have erased what I wrote earlier because we already did this math. 1 mole is 180 grams. All right. So let's go ahead and do the math. 10 divided by 180 is equal to 0.0556 moles. All right, so we know we have this many moles of glucose. So our 90 grams of water is 0.090 kilograms. So I'm going to put my 0.0556 moles that I just calculated, and I'm going to divide it by 0.0900 kilograms of water. So moles over kilograms, that is molality, right? So 0.0556 divided by 0.090, and you've got 0.618 lowercase m molal. Did you see that your molality value, oh, sorry about that, your molality value is different than your molarity. So I showed you step by step how to convert percent by mass to molarity and percent by mass to molality. In the next videos, we'll do other conversions, okay? We'll do one concentration unit to another. So, yep, stay tuned.